Good morning grade 6. Welcome back to grade 6 mathematics class. Hope you all are doing great today. Let's do an activity today. So for this activity, you're going to need colored paper, your geometry box and a pair of scissors. So I hope you have got them now. So now you need to draw polygons on the colored paper. So you have to draw a quadrilateral, a pentagon, a hexagon, a heptagon and an octagon. So a quadrilateral is a polygon with 4 sides, whereas a pentagon has got 5 sides, a hexagon has got 6 sides, a heptagon has got 7 sides and an octagon is a polygon with 8 sides. So once you are done with drawing these polygons on the colored paper, you can cut them out. You have to cut out all these polygons from the colored paper. So cut and take out the polygons. Now if you are done with that, let's move to the next step. Now take the first polygon, the quadrilateral. Now you have to select any one vertex of this quadrilateral and you have to draw diagonals from that vertex. You have to repeat the same procedure for all the polygons. Let's consider the case of quadrilateral now. So the quadrilateral has got 4 sides and each side is represented by the variable n. Here n is equal to 4. Now you can choose any vertex. I am going to consider this vertex here. It has got 4 vertices, 1, 2, 3, 4 and 4 sides. So you can choose any vertex. I am choosing this vertex. So from this vertex I am trying to draw diagonals. So how many diagonals can I draw from here? See, I can draw one diagonal like this. Now can I draw any more diagonals from this vertex? No. You will see you can draw only one diagonal from any vertex. Let it be this vertex, then also you can draw only one. If it is this vertex, then also you can draw only one diagonal. So in the case of a quadrilateral, you can see you can draw only one diagonal from any given vertex. So what can we write here? The number of diagonals that can be drawn from a given vertex, that is equal to 1. And can you try to relate it to the number of sides? What is the number of sides of this quadrilateral? It is equal to 4. And how many diagonals could be drawn? Only 1. And how can you relate 4 and 1? 4 minus 3 is equal to 1. So can we say the number of diagonals that can be drawn from any given vertex? In the case of a quadrilateral, it is equal to n minus 3, where n is equal to the number of sides. Now what about the number of triangles formed in this case? See, when I draw a diagonal like this, there are 2 triangles formed here. So the number of triangles formed is equal to 2. We know the number of sides is equal to 4 and the number of triangles formed like this is equal to 2. How can you relate 4 and 2? Can we say the number of triangles formed is equal to n minus 2, where n is the number of sides? Let's write n minus 2. Now let's verify if these expressions hold true in the case of the other polygons. See, let's take the next polygon. So this is a pentagon. Pentagon has got 5 sides. Now I had chosen the vertex here. From this vertex, how many diagonals could I draw? See, 1, 2. I could draw only 2 diagonals from this vertex. You can try with the other vertices and you will see that you can draw only 2 diagonals from any given vertex. So the number of diagonals that can be drawn from a given vertex here, it is equal to 2. Now, we had got an expression for the number of diagonals and that was n minus 3. Let's see if this holds true. N minus 3, n is equal to 5. So n minus 3 becomes equal to 5 minus 3, it is equal to 2. So this expression holds true for a pentagon. Now what about the number of triangles formed? There are 1, 2, 3 triangles formed here. So what was the expression we got to find the number of triangles formed? That was n minus 2. So let's see if this holds true. N minus 2. Here n is equal to 5, so it becomes 5 minus 2, which is equal to 3. See, the number of triangles formed is equal to 3 and hence This expression holds true in the case of this polygon also. Let's see the next polygon, hexagon. It is a polygon with 6 sides and I had chosen the vertex here and I could draw 1, 2, 3 diagonals in this case. You can try with the other vertices, but here the number of diagonals that can be drawn from this vertex is equal to 3. Let's check the expression n minus 3. This is equal to 6 minus 3 and that is equal to 3. Yes, this holds good in the case of hexagon. Now what about the triangles formed 1, 2, 3, 4? There are 4 triangles formed here. So let's check the expression n minus 2. N minus 2 becomes equal to 6 minus 2 and it is equal to 4. Yes, the expression n minus 2 holds true for hexagon. Now we have to verify if the expressions n minus 3 and n minus 2 hold true in the case of the other 2 polygons, that is heptagon and octagon. So you can tabulate all your observations in a table like the table given in page number 124. And when you observe the results, you will see that in general, we can say the number of diagonals that can be drawn from a given vertex of an n-sided polygon is n minus 3. And the number of triangles formed when diagonals are drawn from a given vertex of an n-sided polygon is n minus 2. I hope this is clear to you. You can go through this given under the heading Maths Lab activity in page number 123, and you also have to go through the Hodes exercise. There are few more activities and exercise mentioned in this chapter. One is the Hodes exercise, then there is enrich yourself, maths around us and highlights. Please make sure you go through all of these. Now that's all for today, children. We have come to the end of this chapter. So in the next class, we'll discuss the questions from revision time exercise. So before that, make sure you go through all the concepts and exercise we learned in this chapter. So see you all in the next class. Take care. Bye.